So let's look at the estimating large numbers unit in AMDM. We estimated crowds. Uh, Either they were lined up in a parade setting or in a big large crowd like on a football field or something like that, or in a shopping mall. We also did estimating crowds in bleachers, whereas bleachers had a little bit different form of the way the people lined up. So we used a different rule of thumb for bleachers as we did for just mobs of crowds. We also estimated large numbers given conditions on things such as social security numbers and zip codes. So let's get on with it. Let's review how we did this. When we were estimating a large crowd along a parade or in a park or something like that, we had to find the area of the crowd. So we have a 3-mile long section, so that's 3 times the length of a mile, because we want to get this in feet, because remember our rule of thumb is one person per 2.5 square feet. That came from the 5x5 square. We fit 10 people in there, so that's really where that came from. So 5,280. That'll give you the length of the parade. The width of the parade is 12 feet, but it's both sides, so it's times 2. So we want to go ahead and multiply that all out. You can do it on the calculator if you want. When the numbers get big, it's probably beneficial to use a calculator. 5,280 times 12 times 2. And you end up with 380,160. And of course, that's the area of the crowd, how many people can fit, how many 2.5 square feet are in there. We divide by 2.5, and your answer should be 1,500 or 152,064. Now, remember, this is just an estimation of large crowds, so I wouldn't really include that 64. It's not really logical to say that it sounds like an exact amount when you don't really know that. So you'd say 152,000, or you could even say 150,000, really, and it would be a close estimate. Okay, so there's the crowds. Crowds for bleachers were done a little bit differently. If you remember, we went out to the bleachers and we sat comfortably. We found out that 7 people per 10 feet worked pretty good where people sat comfortably. So at this point, we just want to go ahead and calculate all the different parts. So we're going to start out with, well, we've got 60 feet long. That's each row. How many rows do we have? 25. And that's 25 rows in each section. So how many sections do we have? It's times 7 for 7 sections. And you could shorten this up a little bit. This 10 goes into this 66 times. So that just becomes a 6. So I got 7 times 6 is 42 times 25 times 7. At this point, I can't do any more in my head. So I'm going to use the calculator for the rest. 42 times 25 and times 7. And you should have gotten 7,350 people. Again, that's pretty good. You could either do 7,400, or 7,300 if you want to round down. Either one of those would definitely be acceptable, and it's just a rough estimate in the end anyway. Okay, so there's how you do the crowds. Let's take a look at zip codes. Remember, on the zip codes, zip code has 5 digits, and what we want to do is we're going to multiply the possibilities for each digit or each place value. So if you look at the Georgia zip codes, what's the first digit have to be? It's either got to be a 3, or a 3. So you really only have one possibility for the first digit. What about the second digit? It looks like it's either a 0, or a 0. You only have one choice for the second digit. And on the third digit, you can have either a 1, a 2, or a 3. So that is 3 choices for that. There are no limitations on the others, so there are 10 choices for the next digit and the last digit. So 10 choices. So multiplying this all out, you end up with 3 times 10 to the second power, or 3 times 100, which is 300 zip codes. And that's how you calculate that for anything. Just list out your possibilities for each place value, multiply them all together, and that will be your available options. And there you have it. There's estimating large numbers in the AMDM Unit 1. I hope that helps, and thanks for watching.